of just a reminder of what's due in the future, okay, so that we're all on the same page. You have your schedules, and all this is on your schedule, but it's nice to have that auditory reminder as well. So on Sunday was due the course agreement form, and then that lab orientation, not the lab orientation, sorry, the orientation to Learn Smart. And I made a list of people who didn't have it done, and all you guys are good. So there are still some people who didn't do it. So for the virtual people listening, make sure you get those done. You can still get partial credit. It'll just be a little late. So coming up Wednesday, what is due by midnight? Remember, our assignments are always due Sundays and Wednesdays. So Wednesday by midnight, you need to finish those Chapter 1A questions, and that's on scientific notation and significant figures. And I'm going to do a review now, so if you still have an attempt left and you haven't got 100%, try it again. Go for that 15 out of 15 on it. And then also the discussion for 1A, and that's due by Wednesday at midnight as well. So most people have done that. You guys have been doing a great job asking questions, answering each other's questions, and then even just letting me know what people are having trouble with. So those two things are due on Wednesday, and then the next assignments are due Sunday. Just to put those up here as well. We have the 1B, right? Chapter 1B. Questions, and these are homework. And that's going to be on conversions. So we're going to do conversions today. If I don't get through them all, I'll be working more on Thursday and posting that video. Okay. And the discussion will also be. You'll kind of notice a trend.
Folder 3.
I'm sorry, what's that?
Is it folder 3? 1B.
I believe it's in folder 2. Yes, it'll be in week 2 folder. So I think, are the chapter 1A questions in week 1 folder? And then these are in week 2. I believe. I can double check on that. I posted an announcement on Blackboard with a reminder as well, so that'll help me find it. But if I'm wrong on that, I'll make sure make a correction and send out an announcement. Because then week 3 will be chapter 1C questions. Okay. Anything so far? I'm going to switch over to this guy so that it's not as muffled. And we're going to start by reviewing scientific notation. So one of the things I noticed in the discussion was people getting confused when the negative sign was there. So we had talked about counting significant figures when a negative sign was present, but we didn't talk about changing it into scientific notation. So my advice to you, pretend the negative sign isn't there, and just do what you would normally do if there was no negative sign, okay? And then when you're done converting it or changing it into scientific notation, just add the negative sign back in. Okay, but the steps are all the same. We're not changing anything. So let's try this first one. So it's negative 27.10. Okay, so I'm going to start by just pretending the negative's not there, and I'm going to approach it like I had been last time that we did these, last week. So I'm going to start by counting my sig figs, because remember, we want to keep our significant figures. And when I change this into scientific notation, I'm going to be moving the decimal point around, and I might get confused at what my original significant figures were. So start by counting. You always start at your first non-zero number. So I'm starting at the 2. Okay? If it's not a 0, it matters. So that's why the 7 and the 1 are also going to count. It's only the zeros that sometimes count and sometimes don't. So in this case, does this 0 count?
Yes.
Why?
Because
there's a decimal, and because you already started counting. So you need both of those to apply for the 0 to count. So we started counting at the 2, and since there's a decimal point, the 0 after counts. So we have a total of 4. Write that up here, just so that once I'm done, I can double check. So 4 SF, 4 sig figs. Okay, so now for scientific notation, the rules are that you want one non-zero number to the left of the decimal. So where is my new decimal point going to go? Between what two numbers?
2 and 7.
The 2 and the 7. because that will leave just 1 to the left. Okay, so I'm going to write over here 2.71, and I'm going to keep the 0 because we said it was important. Okay, so that's making sure you're keeping the sig figs. So now we need to figure out what the exponent's going to be. And that's how many times you move the decimal. So we move it once, right? So it's going to be 1. But what is it going to be? Is it going to be positive or negative? And this is where I think people were getting confused because of the fact that the negative sign was there. Okay?
Is it negative and positive?
It's going to be positive. Okay? The reason it's positive is because we're pretending the negative's not there. So is the original number greater than 1 or less than 1 without the negative?
Less than 1.
27. Is 27 greater than 1 or less than 1?
It's greater than 1.
It's greater than 1. Okay? So that means if the number was larger than 1, we have a positive exponent. The other way people remember it, if I move to the left, it's going to be a positive exponent. If I move to the right, it's going to be a negative exponent. Okay? So we're ignoring the fact that the negative's there when we're figuring out the charge on the exponent. We're pretending it's just like a regular old positive number that we've been dealing with this whole time. Okay, so it is going to be a positive exponent, but when we're done, we need to keep that negative sign. So I understand why people are having trouble with the negatives, because yes, technically that number is less than 1. But we want to do it pretending that that negative's not there. Otherwise, the exponent's going to be incorrect. Questions on this one? You're still kind of confused. We've got a couple more to do, so hopefully that will help. All right, let's start by counting the sig figs in the next problem. Where's our first sig fig? Where do we start counting?
8.
8. Okay, so a lot of people I saw as well were thinking, oh, there's a decimal. That means the zeros count. Yes, it does, but they don't count unless they're after the first non-zero digit. Okay, so all of these zeros here are not going to count because we can't start counting until we get to our first non-zero. So the 8's are first, so that means 2 is going to count. Does that last zero count? This one is. The reason why is because of the decimal, and we started counting already. So a total of 3. All right, so where do we want, if we represent that number in scientific notation, where do we want our new decimal to be?
Between 8 and 2?
8 and a 2. We want just 1 to the left. So I'm going to write 8.2, and we're going to include that 0 because we just said it was important, it was significant. Okay, so to figure out the number or the magnitude of the exponent, we're going to see how many times we have to move the decimal to get it to where we put our new one. I'm not even sure. 1, 2, 3, 4, 5, 6 times. This time we move to the right. So remember, we're ignoring the negative sign. We move to the right. The original number was much, much less than 1. Right? It was 0.00000 something. So in this case, are we going to have positive or negative exponent?
Negative.
Negative, right? Negative exponent. We move to the right. Okay, and since there was that negative sign there, we're just going to pop it back on when we're done. So, questions on that one? This next one's in scientific, so we're going to put it in normal. Okay, it has a negative sign as well, but we're just going to treat it like it doesn't, just do the motions. So it's times 10 to the negative third, so it's the exponent portion that is going to tell us how many times to move the decimal and what direction. Okay, before I do any of that, I'm going to count my sig figs. And remember, significant figures are only the numbers before the multiplication sign, so we're just looking at this number here. So how many?
2.
Just 2. They're both non-zeros, so this one a little bit more straightforward, right? You don't have to worry about the zeros. So when we're done, we want to make sure there's just 2. Okay, so the number 3 here as the exponent tells us we're going to be taking this decimal point, we're going to move it 3 times. What direction? Do I want the number to get bigger, or am I going to want the number to get smaller since it's negative? smaller. I want the number to get smaller, so I'm going to move to the left to make it smaller. So 1, 2, 3. What's going to go in those empty spaces? Zeros. If I write it over here, I have 0.0063, and then I'm going to keep that negative sign. So the negative signs are just there to trick you. Pretend they're not there, do the problem like normal, and then just put it back on when you're done. Okay. So counting sig figs, just to be sure, remember, even though there's a decimal, zeros can't count unless I've started counting. So I start counting at the 6, and then the 3 also counts. So I'm still at 2. Right. So my handout. Take a look for any notes you have. Let me know if you have any questions on scientific notation or significant figures. And if you don't, we'll start the conversions. Just give you a minute to look at that while I hand these out. So these conversion factors that I'm handing out right now, especially for the people listening from home, these are posted on Blackboard. They're in the week 2 folder since we're in week 2. And this is just a small list of conversion factors. There's a much more comprehensive, larger list on Blackboard. So one of these sheets is English to metric conversion factors. And that's the one that's more vertical. The other one that you want to hold sideways, horizontal, these are metric to metric conversions. Okay, and what I did was I basically took, so if you look at the conversion factor sheet at the bottom, it says metric to metric, and then it says prefixes, and then it has symbols and factors. I basically took that and expanded it larger. So this is kind of a cheat sheet almost of how all of the different units of measure change. Okay, so what I'm going to do is I'm going to put some problems on the board, and we're going to use these together to figure out what the conversion factors are that we need to use for that particular problem, and then how to use them. Okay, so I have posted a PowerPoint on conversions that some of you may or may not have seen, but that will help explain this as well. What I'm trying to focus on in class is actually working through the problems, because that's usually where people have troubles. All right, what do I have here? Let's start off low. So let's do 56.8 grams, and we're going to go to. Okay, and a lot of times conversion problems are word problems, as you'll see. This is a shorthand way of writing it, so it might say, if you have 56.8 grams of sugar, how many ounces is that? So that might be the word problem that they say to you, but what they're asking is, I need you to take that 56.8 grams and tell me how many ounces. Okay? So this is a conversion problem. So with conversion problems, what we're doing is we're just changing the units. Okay? We're not changing the amount. Like the numbers are going to change, but I'm still talking about the same amount of sugar, for instance. It's just one form is in grams and the other form is in ounces. Okay? So when you want to start a problem like this, your first step is looking for a conversion factor that's going to get you between grams and ounces. So using your sheet to help you focus where to look, figure out what unit of measure you're talking about. So what I mean by that is we're talking about mass. Okay, grams, ounces, those are masses. So you'll notice your conversion factor sheet is separated by length, mass, and volume. So you'd want to look in the mass area to try to find an appropriate conversion. So does anyone see one that goes between grams and ounces? Sometimes it'll take more than one conversion factor. one is that? I already forgot this. Is it the 28 one? 28.35. So what I'm going to do here is I'm just going to write my conversion factor off to the side. Erase this to give us some more room. And it was 28.35 grams is equal to 1 ounce. So notice conversion factors are separated by an equal sign. Okay? 'Cause these amounts are actually equal to each other. So we can rewrite that in a fraction form in two different ways. So we can write it with the grams on the top and the ounces on the bottom, or we can write it with the ounces on the top and the grams on the bottom. So the reason I'm showing you these two ways is because when I set up my conversion factor, which I'm going to call railroad tracks, one of these ways is going to help me solve and the other one's not going to. Okay? So let's go back over here. Now that we have our conversion factor, we can start our problem. So we start it with like this plus sign looking thing, which you'll hear me refer to as railroad tracks quite often. So what I start when I do this plus sign is I'm always going to start by putting a number in this upper left-hand corner. And the number that I'm going to put here is the number in the problem itself. That's how I start. What do they want me to convert? What number? The 56.8 grams. So I'm going to write that here. I'm going to make sure I include my units. Because as I'm doing conversions, I need to keep track of units so I can see what did I cancel out, what do I have left, where am I at? Okay, so bring your units with you. So now that I have my initial number to start with, what's going to go here in this fraction space, right, is one of those conversion factors. I mean, it's the same conversion factor, but represented two different ways. So to figure out which one is going to help me, what I need to know about this plus sign is that this horizontal line here is a division line. Okay, just like with a fraction, whatever's on the bottom is what you're dividing. This vertical line here is a multiplication line. So what I want is to get rid of grams, right? I don't want grams, I want ounces. So that means I'm going to want to put grams on the bottom or on the opposite side of this horizontal line. That way, my grams and grams will be on opposite sides and they cancel. I no longer have grams. So looking at these, it's going to be this one here that I want to use. So imagine just picking this up and popping it right here. Okay, so we're going to put the 28.35, you got to bring the number with it, grams on the bottom, and I'm going to put my 1 ounce on the top. So since my units, my grams, are on opposite sides of that horizontal line, they're being divided, so they cancel. So now, the only units I have left are ounces, and that's exactly what I want. So how do we solve for this? Well, just multiply across. So it's really 56.8 times 1. And we're going to divide it by whatever's on the bottom. And the only thing on the bottom in this case is that 28.35. Okay, so 56.8. Someone want to calculate that for me? Go ahead and give me all the numbers and we'll do sig figs at the end.
2.0035 27337.
Jeez. So this is where you're going to be happy that you know about significant figures because you won't have to report the answer to all of those numbers. So what you'll need to do is report to the correct number of sig figs. So how do you know how many sig figs? Right?
Significant numbers. Only said 6.8 is 3. It's a good significant number. So we need 3 numbers out the bottom.
Right, so you're looking at the original number. Okay, so 56.8, you just said that was 3 sig figs, which is correct because they're all non-zeros. And that's how many you're going to want in your answer. So what I don't want you to do is use the conversion factor to figure out significant figures. Okay, never use the conversion factor. Those are called exact numbers. They will not be considered when you're counting sig figs. So you're only using the number in the question itself to figure out the sig figs. Okay, so 3, we want 3 here. So 1, 2, 3. Always look at the number next to it. Is that going to stay a 0?
Yes.
Yes, it is. So we have 2.00, and then don't forget your units because we're now Units are important. So 2 ounces, and these zeros do count because we start counting at the 2 and there's a decimal. So 2.00 ounces.
So on the test, if we just write 2, it's gonna be wrong?
Yes. Yep.
What about if we just write the whole answer out like that?
2.00. Most of the test questions are multiple choice. But if this was a fill in the blank, you'd need to put 2.00. And you'd have to write the OZ unless it was already on the side. You know, when you have a fill in the blank and it already has the units next to it. And I always double check the fill in the blanks. So if you wrote something a little different, but it's still correct, I'll change that for you. You see what I mean? So like, if you see, because it'll let you look at your test when you're done, but you just get a view at once, you're not going to be able to go back and look at it a whole bunch of times. So if you see a problem that you think you got correct, that it marked wrong, just send me an email. Say, hey, will you check 14 and 17 for me? Because I think I got them right. And I'll check them. So, any other questions on this one? But yeah, if you forgot the zeros, for sure it would be counted incorrect just because you need 368. Let me erase this. Let me try a couple more. So, yeah, 50 inches to meters. I don't want to, that's a little harder to see. Okay, so in this one, we're taking half an inch, basically, right, 0.50 inches, and we're going to convert that now to meters. So first step, find some significant figures. Geez, find some conversion factors. You could count the sig figs if you wanted first too. So do we have any conversion factors that go directly from inches to meters?
No.
No, so that means we're probably going to need more than one. Okay, so can we get from inches, are there any with inches in it at all?
Centimeters.
Centimeters? Okay, so I'm just going to write that down as a possibility. Okay? And we'll see what that looks like. So we have the centimeters one, 2.54 centimeters equal to 1 inch. Okay, so if this is going to be more one step, I'm going to just kind of write the steps for it. So I'm starting at inches. If I use that, I will be in centimeters, right? So I'm going to call this conversion factor 1. So using that conversion factor, it'll get me between inches and centimeters. Okay. Well, now I'm in centimeters, and I want to get to meters. So centimeters, meters, this is metric to metric now. So far, we've just been dealing with English to metric. Everything we've been using, it's been going between ounces and grams, for instance, right? Grams is a metric unit. Ounces is an English unit. How did I know this was metric to metric? Your clue is always there's a letter in common. So centimeters and then meters. Okay, since they have that letter in common, they're both a meter form. It's metric to metric. So I'm going to switch and use this conversion factor sheet to find my next one. Okay, so if you have a metric to metric situation, use this guy. And what you're going to want to do is it's arranged similar to that other one. Notice you have a meter section, a gram section, and a liter section. Okay? You also have the prefixes over here. So we're doing centimeters, so we want to follow down where the centi is. Follow it over to the meter section, and then notice we have a conversion factor with the equal sign. Is everyone following me? So I'm looking at the, fourth row down, and the fourth column in. So it's 1 centimeter is equal to 10 to the negative 2 meters. Can you find that one? Okay, so this is a conversion factor as well. call that number 2. And what this will get us from is from centimeters to meters. So we can get to meters using that. Notice it is 10 to the negative 2, so it's scientific notation basically. So this is why we learned about scientific notation, is to use those conversion factors. So once you have a plan, you have all the conversion factors you need, then you can start with that plus sign. Okay? So let's see how it looks when there's 2 steps. So this one's a little bit harder, right? Because we had to use 2 different conversion factors. So we're always still going to start, though, with our original number in the original question. So that's what's going to go in this upper left-hand corner. We're going to put 0.50, and we're going to put inches. So I'm here. I want to get to centimeters first using conversion factor number 1 there. Okay. Now remember, we can put either the centimeters on the top or we can put the centimeters on the bottom. What do we want in this case with that conversion factor?
Centimeters on top.
Centimeters on top. So that means I'm going to take this 2.54, that side of the equation is going to go on top, because that'll put the 1 inch on the bottom. And we need it down in the denominator so that these inches are on opposite sides, that way canceling out. So if I stopped here, I'm in centimeters. But I'm going to keep going because it's asking for meters, not centimeters. So going from centimeters to meters, I'm using my next conversion factor. And in this case, do I want the 1 centimeter portion on the top or on the bottom? The bottom this time. Because remember, I'm trying to get rid of centimeters. So I'm going to put the 1 centimeter portion on the bottom. That'll put the 10 to the negative 2 portion on the top. So centimeters are canceling because they're on opposite sides of that horizontal line. So now when I calculate, the only units I have left are meters. So what I'm going to do over here is just write what we're doing. Remember, we're multiplying across and dividing by what's on bottom. So it's going to look like 0.50 times 2.54 times 10 to the negative 2, and then all of that divided by 1. So if you have your calculator, you might want to try this just so that you can get practice with that scientific notation. Okay, so times 2.54. And then dividing by 1 just gives you the same thing. So your calculator will give you one of 2 answers. 127, or yes. So your calculator might give you the scientific notation form, or it might give you the decimal form. Just depends upon how you have it set up. These are not my final answers because we still need to take into account sig figs and we need to add the units. Okay. Everyone good with getting these if you? Okay. So let's check sig figs. So we're going way back to the original number. How many sig figs in this number? 2. Start counting at the 5, and that 0 does count because of the decimal. So we want just 2 over here. And it doesn't matter which one you do it to, okay? But where are we going to start counting in this guy? At the 1. So that means the 1 counts and the 2 counts. Always look at the number next to it. So you're going to stay at 2 or go up to a 3? You're going to go up to a 3. So we get 0.013. Is it raining again? Jeez. Stormy days. So either of these are acceptable answers. And then don't forget the units. So we're in meters, right? Either one of those. Now, the question might specifically ask for it in scientific notation. And you've probably seen that if you've tried the chapter 1 homework, where it gives you a little box before the multiplication sign to fill in, and then it gives you a little box to fill in for the exponent. All right, questions on this one? with conversions, it's really just doing a lot of practice problems. Okay, so that's what we're gonna do for this rest of this hour. Just a whole bunch more. All right, can we erase this then? Right out. All right, what do I have next? Quarts to milliliters. So we've done mass, we've done length, let's do volume. 0.75 quarts to milliliters. So for this one, when I initially look at it, do you think it's metric to metric or English to metric?
English cemetery? Well,
It is English to metric. So if you're not sure, just look and see if there's a letter in common. And there's not, right? I have quarts with a T and milliliters with an L. If it was liters to milliliters or kiloliters to milliliters, then it would be. You'd have that letter, that word in common. So if it's English to metric, you're going to start at least. Doesn't mean you're not going to use any metric conversions, but you'll at least start with something from this table here. So you'll look in the volume section, so the third section down. Do we have anything that goes from quarts to milliliters?
liters, what?
No, but we do have liters to quarts. Okay, so we can get into the metric region, right? If we're in liters, we can then go from liters to milliliters. So if you can't find something going directly to mils, try to find something that gets you in the metric area. Okay, so we're going to use, and notice there's two different ones you can choose from. You have the 0.947 liters is equal to 1 quart, and you also have 1 liter is equal to 1.06 quarts. You can pick either one. You're still going to get the same answer. As long as you're setting it up so you're canceling out what you don't want and keeping what you do, it's going to get the same answer. Okay, I think I did a problem like that on the PowerPoints where I did it 2 different ways to show you that it does in fact get the same. So I'm just picking the top one because that's the first one I probably would have noticed and would have ended up using anyway. So once I find one, I just kind of stop and I'll keep looking and see if there's 5 more just like it. So this is going to be my first. So that's going to get me from quarts to liters. So now I want to go from liters to milliliters. So what conversion factor sheet do I need to look at now? The metric to metric one. Okay. So I need to go all the way down to the milli. Okay, because this is milliliters, it's not megaliters. Notice you have, for prefixes, a megaliter at the top and then a milli way down. That megaliters, this is going to be a very pronounced capital M if it's megaliters. Okay, so this is milli. And usually we don't do megaliters, it's milliliters, especially in lab. So we're looking at the milli, and we're going to follow it all the way over to the liter section. So 1 milliliter, what is it equal to? 10 to the negative third? All right, so this guy will get us from liters to milliliters, as long as we set it up right. Once you have your conversion factors, go ahead and start. What's going to go in this upper left-hand corner? 0.75 quarts. So I'm going to use the first conversion factor I found to get rid of quarts. So what do I want on the bottom? What part of that? The 1 quart. I want it on the bottom to cancel, so that's going to put 0.947 liters on the top. So quart, canceled. So now I'm here, I'm in liters. So second step, using that second conversion factor here, is going to get me out of liters and into mils. So where do I want the 1 milliliter to go, top or bottom? Top, yes. That's going to put the 10 to the negative third on the bottom. Liters tricross, divide the numerator by the denominator. So I'm going to get 0.75 times 0.947 times 1, and 1 times 10 to the negative third. Well, I advise on this one. So notice you have scientific notation on the bottom. Make sure, and not all calculators are this picky, but you might want to put that in parentheses when you divide. Okay, depending upon your calculator, I know mine gives me the wrong answer unless I put the scientific notation in parentheses when it's in the denominator. And you can also, since you know how to, you can change that into normal notation if you want, just by moving that decimal 3 times. I got 710.25. Anyone do something different? No disagreements, we'll count sig figs. All right, so going way over here. How many sig figs in the original number? 2, exactly. So we want 2 over here. Start counting at the 7. The 1 also counts. I'm going to stop counting there. Look to the number next to it. Does that stay a 1?
Yes.
Yes, it does. A lot of students write 71 and stop. That's incorrect. Okay, it's the correct number of sig figs, but I was at 700 and something. I can't go from 700 down to 70. That's a different order of magnitude. So that means I need to put a number here, a placeholder number, that will not be significant. So what's the only number I can use that will not be significant? A 0. So I'm essentially, in this case, I'm keeping this 0. As long as I don't put a decimal there, so I get rid of the decimal, it's not significant, and I'm still at 2 sig figs. And this way, I'm still in the 700 range. I didn't go from 700 down to 70s. See a couple like this in lab this week as well, where you'll have to make sure you're keeping zeros so that you're still the same order of magnitude. Okay. Now, before I'm completely done, I need to put my units. So in this case, milliliters. So 710 milliliters. Okay. So, what questions do you have on this one?
So you don't need to bring that exponent over. Just 10 minus 3, you don't need to bring it over, just leave that alone, right? Divide.
Right.
Okay.
Yep, once you divide it, I mean, if you, depending on your calculator, it might have given you an answer in scientific notation and kept that exponent, but most of them spit it out in normal notation. So, if you have one of those really fancy calculators, you can actually, I think there's just a button you can press that changes it from normal to scientific for you. So, I have the cheap calculator, so I'm not sure how to do that, but I know they can do that. Right. I'm going to try, this is very similar to one in your homework, so I wanted to do it on the board because I thought this was one of the harder ones. Okay. I think it's actually the exact same units, it's just different numbers. So the trick about this one is that it's giving us pounds and ounces, 2 different units of measure. So this would be a question if you're going in a health-related field. If you had a baby that was born, kind of a big baby, but 8 pounds, 8 ounces, how many grams would that be? Okay, so that's what we're going to figure out. So this is going to require an extra step because we need to take this 8 pounds, 8 ounces and get it all in the same unit before we start the conversion. Okay, so you can either get it all into pounds or you can put it all into ounces. Now, I prefer to put it all into ounces just because that way I'm not going to have a fraction or a decimal. I'm going to have a whole number, and that just looks nicer to me. So is everyone cool with doing it all in ounces? So our first step is going to be to take this 8 pounds, So I'm breaking it up into chunks and getting it into ounces. Okay, so it's like a side conversion before we get started.
I have a question.
Yes,
If we know that 16 ounces equals a pound,
you can absolutely use that as a conversion factor.
okay.
Yes. So like I said, this one here, this is just a small snippet of them. So there's many more. Actually, when you go into your course content, before you even get into any of the week's folders, I have a thing that says references for chapters 1 through 9. There is a much bigger conversion list there you can use. But I just didn't want to print out 5 pages of conversion factors for you. So instead I brought like a short list. But yeah, we can use that on this. So 16 ounces in a pound, you can use that as a conversion factor if you know it. You can search a conversion factor online if you want, use that one. Okay. So let's use it and see. 16 ounces equals 1 pound. Right? So all I need is that one conversion factor, one step. What do I start with in my upper left-hand corner? 8 pounds. So when I use that conversion factor, how do I want it? What do I want on top? Let's put it that way. The ounces, so the 16 ounces, the 1 pound on the bottom. That way pounds cancel. So to get ounces, I'm just doing 8 times 16, which I can't do in my head, so someone do that for me. 128. That's 128 ounces. That's not the total of the baby though. What do we need to do at this step? Add the 8 extra ounces. Okay? I'm going to add the 8 from up here. Bringing it down. This one I think I can do in my head. 136. So what I'm going to do up here is I'm going to erase this and I'm going to replace it with all ounces. Okay? Before I do that, let's talk briefly about significant figures with a number like this, because this is a hard one to figure out sig figs. Okay? 8 pounds, 8 ounces. Right? So you look at 8 pounds and how many sig figs do you see? 1. But it's also 8 ounces. Okay? So you need to count both of these for a total of 2. Because it's like saying that baby was 8 point something. That's what that 8 ounces is. It's that extra sig fig. So this would be 2. The reason I'm not rounding this to 2 sig figs is because you never want to round to sig figs until you're completely done with the problem. So I'm not going to round this up to 140 because it's going to give me a more accurate answer if I'm using all 3 digits as I go through. Okay, but I wanted to count the sig figs before I change this and replace it with this number. Okay. See how this is confusing, probably? Right. Erase this section. Now that we have it all in ounces, we know that our original number had 2 sig figs. Okay, this does not, but our original did. Let's go from ounces to grams. Do we have a conversion factor that gets us from ounces to grams? Is that 28 one? Okay. 28.35
Yep.
grams in 1 ounce. Or is that factor? No, I think that's right. Okay. So this will be a 1 step as well. We have our conversion factor. We start our railroad tracks. We're going to put that 136 is how we're going to start it. That ounce kind of looks like I'm running 1,300. Okay, so what do we want on top? Grams or ounces? Grams on top. Gosh, when you put a baby's weight in grams, it seems like they're really big. So we have ounces canceling because they're on opposite sides of that horizontal line. And to figure out the final answer, we're going to take 136 times 28.35. Unless someone already has an answer. by 9.6. So we need to go back to our original, which was 8 pounds, 8 ounces. So this was the 2 sig figs. And make sure we just have 2 in our answer. So it's another one of those where we have to round. So we have 1, 2. Look to the number next to it. Does that stay at 8 or does it move up to a 9? 9. But we're not going to just write 39 and be done, because this is 3,000 something. So we need our answer to be 3,000 something. So look at all the spaces before the decimal. So I have 2 spaces still that I didn't fill. So instead of putting 5s there, what am I going to put? Any numbers that aren't significant? Zeros. So I'll put 2 zeros instead. Now I'm still in the 3,000 range, but I only have 2 sig figs. And my units are? Grams, yes. So now it's looking like that baby's huge, but it's not. 3,900 grams. Guess that's why they usually measure weight in kilograms, huh? Questions? All right, keep going. So now we're going to do one that's similar to what you'll see in lab, for lab 3 anyway. 3.6 meters squared. So this is different than what we've seen because of the squared. Okay, and what you're going to see in lab is actually cubed as well. So we're going to look and see how we do a problem when the units are squared or when the units are cubed. So to do this, we're going to first of all treat it like the other ones and just find a conversion factor. One that'll get us from meters to centimeters. Okay, so meters, centimeters, is that English to metric or metric to metric?
Metric to metric.
Metric to metric, we have that letter in common. The M, meters. So we look at the conversion factor sheet, or cheat sheet, sideways one, and find one from centi to meters. So you want to go down in the prefix line and find where the centi is and then follow it over. So what is it? 1 centimeters equal to, is it 10 to the negative 2? I write that backwards. Well, that's right. All right. So, how do we do this? You can do it one of 2 ways, and I'll show you both ways, and you can pick which one you like better. Okay? So, one way is to just, now that you have your conversion factor, start your railroad tracks like normal. We're going to start with what was given in the problem, 3.6 meters squared. Now the next step would be to take this conversion factor and put it here, right? So if you do that, you still want to follow the same rules. Cancel out what you don't want, keep what you do. So you're going to want to put the meter portion on the bottom. So I put the 10 to the minus 2 on the bottom, the 1 centimeter on top. If I use this, notice I'm only getting rid of one of those 2 meters. So if I do it this way, I'm going to want to make sure to write the same exact conversion factor twice in a row. Because that way I have 2 meters, and those 2 will cancel out these 2. Also what's important is notice I want it in centimeters squared. So if I take a centimeter and I multiply it by centimeter, I will then have centimeters squared. Okay. The other way to do it is if you take your conversion factor itself and square it. So you can square the conversion factor first and then just put 1 here. So what that looks like is you want to square, so let's start on this side. If I want to take this and square it, what is 1 squared? Just 1. So it's going to become 1, and then centimeters squared would become centimeters squared. Now I need to square the other side of the equation. So what I'm doing is I'm taking 10 to the negative 2 and I'm squaring it. So you can enter that in your calculator to figure it out, but it is 10 to the negative 4th when you square 10 to the negative 2. Okay, so I just squared that number. And then meters squared would look like this. So you basically have a new conversion factor that you could use. And your problem would look like this. Okay? Either way is going to get you the same answer. So whatever way makes more sense in your head, do them that way. Okay? A lot of people like this because then they can visualize it better. But some people would rather just convert the conversion factor and just do one step. So let's solve it. 3.6. And 10 minus 2. Minus 2. Here. 6. And what I get is 3.6 times 10 to the positive 4 in both cases. Centimeters squared. Your calculator might also have 2, 3, 4. Might give you that number, 36,000. This would just be the normal notation form, right? 10 to the positive 4, we'd want the number to get bigger, so we'd move that decimal 4 times to the right, giving us 36,000. The nice thing about metric to metric, because this is our first solely metric to metric problem, right? We haven't done any English to metric conversion factors in here, is that notice the number itself, the numbers stay the same. It's just where the decimal point is that changes when you do metric to metric. So going between meters and centimeters or kilometers and millimeters, you're really just moving a decimal point to get from one to the other. But the numbers themselves are still going to be present in your final answer. So we have a 3 and a 6 here, we're still going to have a 3 and a 6 is what I mean. Questions on this one? Do you want to try another one like this, or do you want to move on?
I want to try
Yeah,
that
one
one
more.
Another one? Should we do a cube, since we'll see cubed in lab?
Yeah.
Okay. Think of, let me see in lab. I think we see inches cubed. Let's do that. I think we see an inches cubed to centimeters cubed in lab. Now I gotta think of a number. Whenever I make up numbers, we usually end up getting a really weird answer. I haven't tried it out yet, so I hope this turns out okay. So either way, we'll be able to solve it. The final answer might just be a little kooky. So now we're still doing where we have the units raised to a power. So inches cubed to centimeter cubed. So your first step is still to just try to find a conversion factor that'll get you between inches and centimeters. We're going to worry about the cube when we get there. So I think we have one. Is that 2.54 centimeters? So notice inches, centimeters, English to metric this time. Right? There's no letter in common. So this would be the conversion factor you're using. Now you can either cube that conversion factor, and if you cube that conversion factor, you want to make sure to cube the numbers in it too. Okay, so it's going to look like 2.54 cubed centimeters cubed is equal to 1, whatever that is cubed, which is just 1. Okay, so that's how you would cube it. Or you can put it on your railroad tracks 3 times how it is. So, anybody have a preference for how we do it? The first one where you cube it first and then put it in? Okay, we'll try it that way first. So how do we start it? What's going to go in this upper left-hand corner? 5250 inches cubed. So if we want to put the cubed version of our conversion factor, let's finish solving for it. What is 2.54 cubed? I think it's 16 something.
You want all the numbers?
I do. You want to use all the numbers until you get to the end. So
16.387064.
7064. Is that right? 387064?
Mm-hmm.
Okay, thank you. Centimeters cubed is equal to, and then 1 cubed is just 1 times 1 times 1, so it's just 1. So this would be our new cubed conversion factor. So you only have to use it once because it's already cubed for you. Do I want the 16, that huge number, it's not a huge number, but the long number, on the top or on the bottom? I want it on the top. That's the centimeter part. And that's what I'm looking to get my answer in, is centimeters cubed. And the reason we're keeping all the digits is because you don't want to round until you're at the very end and you're figuring out sig figs. It's going to get you a more accurate answer. If you rounded it, you might be off by a little bit. When you're looking at your multiple choice or whatever, you're going to go, oh, I don't get that answer. So the 1 inches cubed on the bottom. Now, inches cubed cancel. See, I told you this was going to be horrible. Look how huge this number is going to be. So to fit answer or to solve, we're taking 5250 and we're multiplying it by that huge number. 87064. If anyone gets an answer for me, feel free to shout it out.
86,032.086.
086?
Yes, ma'am.
Okay. Now we take into account sig figs. We don't want to report that messiness. So let's go back. How many sig figs do we need?
4.
So start counting at the 5, the 2 counts, the 5 counts. Does that 0 count? That's the tricky part.
3.
It doesn't. No. So there's just 3. Why does the 0 not count?
There's no decimal.
There's no decimal. You have to have a decimal, or the 0 needs to be between 2 non-zero numbers. Neither of those apply. So we have 3 sig figs. So this is going to be messy, because how do we get 3 sig figs out of this? So let's go over here and look. Actually, I'm glad it turned out this way, because I think one of your lab problems makes you do it this way too. So 3 sig figs, so let's just count. 1, 2, 3. Look to the number next to it. Does that stay a 0?
Yes.
Yeah, it does. Okay, so my options, if I represent this in normal notation, is it even possible to write it in 3 sig figs? Because what I have here is 8, 6, and a 0. Now I need the placeholders for these 2 numbers. I need to stay in the 86,000 range, right? So what I told you before is to make sure you're putting zeros there. But how many sig figs is that? 2. So this number, if I want to represent it in 3 significant figures, it's impossible to do in normal notation. So if I want to represent it to the correct number of sig figs, I have to do it in scientific. Okay, and you do have one like this on your lab where you're going to have to represent it in scientific to get the correct number of sig figs. Okay, so let's put it in scientific notation and then count on our 3 sig figs. And if you have a calculator that does that, you can just press that button and it'll show you, but let's do it the long way. So if I wanted this in scientific notation, where's my new decimal going to be? Between what two numbers? 8 and the 6. Because remember, you want just one non-zero number to the left of the decimal. Okay, so I'm going to write it up here, the scientific notation, so we can see it better. So I'm going to have 8.6 times 10 to the something. We'll worry about sig figs at the end, so just work with me here. So I know it's going to be between the 8 and the 6. Now I need to figure out the exponent itself. So it's how many times I move the decimal, but where's my original decimal? I don't have one, so I'm going to start at the end of the number. Okay? So I have to move it 1, 2, 3, 4 times to get it between the 8 and the 6. So this is going to be a 4. I moved to the left. My original number was much greater than 1. It was 86,000. So does that stay positive or is that going to be negative? So if the number is greater than 1, we want a positive exponent. Okay, so it does stay positive. Now where I'm going to worry about the sig figs. How many did we say we needed?
3.
How many do I have?
2.
How do I make it 3?
Add a 0.
0.
Add a 0. Hardest problem you'll see to get to 3 sig figs. Okay? You wouldn't see this on an exam, but you will see it in math, where you're going to have to represent it in scientific notation just as a 3. We do the hard ones in lab so that when you get to the test, you're like, oh, it's not that bad. So what are my units?
72.
After all that, we still have units we got to put on there. I told you if I made up a problem, it was going to get messy. So you have, I think you do maybe even 3 different conversions like this during lab, so you'll get more practice at it there as well. All right, what time is it? I'll move it over. I guess I'll stop there, because we only go to line 15, don't we?
Yeah.
Okay, so on Thursday, I'm going to be making a video again, doing more problems like this. So it's going to start here and go further. So I'm not going to do the same one. So I would watch the video from Thursday as well. I'm also going to do some temperature conversion problems. And that's a lot easier. You literally have equations and you just plug in a number into the equation and solve. Okay, so it's not a lot of searching for things.
Sorry, the question is, my lab is online. Do I need to go in the lab?
If you chose the virtual option for lab, is that what you said?
No, I'm online now.
Yeah, so you won't need to go into the lab.
Okay.